Welcome to the Deep Dive. We're here to break down complex topics into something clear, something useful, especially for you.
That's right.
And today, we're tackling a really core idea in microeconomics, elasticity.
It sounds technical maybe, but it's actually everywhere.
So our mission today, we want to really unpack what elasticity means, how economists measure it, the different kinds, what influences it.
And crucially, why it matters, why it's fundamental for businesses, for governments, and definitely for you if you're studying economics or prepping for exams.
We'll use real examples, try to paint pictures of the graphs and data, make it stick.
Definitely. So let's jump in with the story. Imagine getting an ambulance bill. Kira, my last did, after a pool accident. Not super serious, but still.
How much was it?
$7,772.42.
For a pretty short trip.
Wow. Yeah, that's shocking. I mean, in a real emergency, you don't ask the price, do you?
Exactly. And even if it's less critical, once the ambulance is there, people often feel, obligated. They don't even think about the cost until later.
Is this common? That kind of cost? Well, the scale is huge. We're talking 40 million ambulance rides a year in the U.S. Costs about $14 billion total.
Okay.
And interestingly, for-profit ambulance companies have been expanding like crazy. They see a big opportunity.
Why? Because people will pay almost anything.
That's basically it. It ties into this economic idea of price unresponsiveness.
Okay. Price unresponsiveness. That sounds like the core of elasticity.
It is. It just means that for some things, like an ambulance ride in an emergency, changing the price doesn't massively change how many people want or need the service.
Unlike, say, cereal. If my favorite brand suddenly costs 10 times as much.
You're switching brands or
Yeah.
eating toast.
Right.
There are substitutes. With emergency services, not so much. That difference in responsiveness is what elasticity measures.
Got it. So how do we actually put a number on this responsiveness? What's the main tool?
The main one is the price elasticity of demand, usually just called PED. It's a ratio. It compares the percentage change in the quantity people demand to the percentage change in the price as you move along that demand curve.
And why percentages? Why not just dollar changes or number of rides?
Good question. Percentages make it a universal measure. It doesn't matter if you're measuring ambulance rides in miles or trips, or buns and singles or packs of 6. A percentage change is comparable across anything. It's unit-free.
Okay, unit-free. Let's try the ambulance example. Price goes from $200 to $210. That's a $10 increase.
Right. And let's say the number of rides demanded drops from 10 million to 9.9 million. That's a drop of 0.1 million.
So how do we get the PED from that?
Okay, step by step. The quantity change is 0.1 million. The starting quantity was 10 million. So the percent change in quantity is narrow 0.110, which is narrow 1%.
Minus 1%. Got it.
And the price change is $10. The starting price was $200. So the percent change in price is $200, which is 5%.
Okay, 5% price increase leads to a 1% quantity decrease.
Exactly. So the PED is percent change in quantity divided by percent change in price. That's negative 1% divided by 5%, which equals negative 0.2.
Minus 0.2. But wait, you said price and quantity always move opposite ways for demand. That minus sign seems automatic.
It is, because of the law of demand. So by convention, economists usually just drop the minus sign and talk about the absolute value. For the ambulance ride, we'd say the PED is 0.2.
Right. So 0.2, what does that small number actually tell us?
It tells us demand is inelastic. A PED less than 1 means inelastic. The quantity demanded changes by a smaller percentage than the price changed. It's not very responsive.
Which explains why ambulance companies can raise prices and potentially make more money. People still need the service.
Precisely. The revenue gain from the higher price outweighs the small loss from fewer rides.
Okay, but you mentioned calculating percentage changes. Isn't there a potential issue there? Like, if gas prices triple in Europe versus fall by 2/3 in the U.S. relative to Europe, the percentages look different depending on your starting point.
That's a really important point. Yes, the standard percentage change calculation does depend on the direction of change. That can make elasticity ambiguous.
So how do economists fix that?
They use something called the midpoint method.
Midpoint method, okay.
Instead of using the initial price or quantity as the base for the percentage calculation, you use the average of the starting and final values.
The average. So halfway between the start and end points.
Exactly. The formula is change in x divided by the average value of x then times 100, where the average is just starting x plus final x2.
Let's try an example. Say price goes from $90.92 with $9.10, and quantity falls from $1,100 to $900.
Okay. The change in quantity is 9 at 200. The average quantity is 1100 plus 900, 2 is 1000. So the percent change in quantity is 9 to 200,000, 120%.
Minus 20%.
The change in price is a 90-20 cents. The average price is 90 plus $1.10, 2 equals $1. So the percent change in price is 1120% plus 20% plus 20%.
Yeah.
So the PED using the midpoint method is 20%. 20% equals 1. Remember, we dropped the minus sign. And the beauty is you'd get exactly 1 even if the price fell from $1.10 to 90 cents. It eliminates the ambiguity.
That makes a lot more sense for consistent calculations.
Yeah.
Especially when you're trying to estimate these things in the real world, which sounds tricky.
Oh, it is. Very tricky. Because in the real world, it's not just price-changing demand. People's incomes change, tastes change, other prices change. You need pretty sophisticated statistics to isolate the effect of price alone.
But economists do estimate these.
Yes, absolutely. There are tables full of estimates, and they show a huge range. You know, gasoline in the short run might have a PED near 0.1, very inelastic. But something like Coke versus Pepsi could have a PED over 3, very elastic.
Wow, okay. And things like housing, airline travel?
Housing is generally estimated to be elastic, maybe around 1.2. Airline travel is interesting. Business travel tends to be inelastic, maybe 0.8, but leisure travel is much more elastic, like 1.5.
Because leisure travelers have more flexibility, more substitutes for that specific trip.
Exactly. It just shows how much this responsiveness varies.
So we've got these numbers, 0.2, 1.0, 1.5, 3. How do we categorize them? What's the dividing line between elastic and inelastic?
Well, let's start with the extremes first. They help frame it. Case 1. Perfectly inelastic demand.
Perfectly inelastic, meaning no response at all.
0 response. The quantity demanded is the same, no matter the price. The PED is 0. If you graph it, it's a completely vertical line.
What's an example?
Think of a life-saving drug where you need a specific dose, like snake antivenom. If you need 1,000 doses to live, you're going to buy 1,000 doses, whether it's cheap or incredibly expensive. You're not quibbling over price.
Right, makes sense. What's the opposite extreme?
Perfectly elastic demand. Here, any tiny increase in price and demand drops to 0. Any tiny decrease and demand becomes enormous, theoretically infinite.
Infinite elasticity. What does that look like?
It's a perfectly horizontal demand curve. Think about something with perfect substitutes, like those pink tennis balls we mentioned. If every other color sells for $5 and you try to sell pink ones for $5.01, nobody buys them. If you sell at $4.99, maybe everyone wants the pink ones.
Okay, vertical for perfectly inelastic, horizontal for perfectly elastic, but most things are in between.
Right, and the magic number is 1. If the PED is greater than 1, we say demand is elastic. The quantity change, in percentage terms, is bigger than the price change.
So people are quite responsive.
Yep. If the PED is less than 1, like our ambulance example, 0.2, demand is inelastic. The quantity change is smaller than the price change, less responsive.
And if it's exactly 1?
That's unit elastic. The percentage change in quantity is exactly the same as the percentage change in price. They match perfectly.
Okay, elastic 1, inelastic 1, unelastic 1. Why is this breakdown so important, especially for, say, a business?
It comes down to total revenue, which is just price times quantity sold, P times Q.
The total amount of money coming in.
Exactly. Elasticity tells you what will happen to your total revenue if you change your price. Let's visualize it. On a demand curve graph, total revenue is the area of the rectangle formed by the price on the vertical axis and the quantity on the horizontal axis.
Like if a toll bridge charges 90 cents and 1,100 drivers use it, the revenue is 90 cents times 1,100, which is $990. That's the area of that rectangle.
Perfect. Now, if the bridge authority raises the toll, say to $1.10, what happens? 2 things are pulling in opposite directions.
Okay, what are they?
First, there's the price effect. Each car that still uses the bridge pays more. That pushes revenue up.
Makes sense. Higher price per unit.
But second, there's the quantity effect. Because the price is higher, fewer cars will use the bridge. That pushes revenue down.
Fewer units sold.
Right, so which effect wins?
Elasticity tells us.
Okay, connect the dots.
If demand is inelastic, PED1, the price effect is stronger. Raising the price will increase total revenue. The drop in quantity isn't big enough to offset the higher price per unit. Think ambulances again. Okay, inelastic means raise price, get more revenue.
Generally, yes. If demand is elastic, PED1, the quantity effect is stronger. Raising the price will decrease total revenue. The drop in quantity is so large, it overwhelms the higher price. Think luxury goods, maybe?
Elastic means raise price, get less revenue.
Correct. And if demand is unit elastic, PED equals 1.
The effects cancel out exactly.
Bingo. A price change has no effect on total revenue. The percentage change in price is perfectly offset by the percentage change in quantity.
Wow. That's incredibly important for pricing decisions.
Absolutely fundamental. And it works the other way, too, for price cuts. If demand is inelastic, cutting price reduces total revenue. If it's elastic, cutting price increases total revenue.
So businesses really need to know the elasticity of demand for their product.
They do, and it gets even more nuanced because elasticity often isn't constant along the same demand curve.
It changes for the same product.
Yeah, think about it. At very low prices, people might be pretty unresponsive to a small price increase. Demand is likely inelastic. Raising the price might boost revenue. But at very high prices, people are already stretched, maybe looking for alternatives. A further price increase could cause a big drop in demand, making it elastic at that high price range.
So the same product can be inelastic at one price point and elastic at another.
Often, yes. That's crucial for finding the optimal price. You don't want to push the price up into the elastic region if your goal is maximizing revenue.
Okay, that adds another layer. So what actually makes a good elastic or inelastic in the first place? What are the driving factors?
There are generally four main factors economists point to. First, is it a necessity or a luxury?
Okay, necessity versus luxury.
Necessities, things you really need, tend to have inelastic demand, like basic food, essential medicine, maybe that ambulance ride. Luxuries, things you want but don't need, tend to have elastic demand, like a fancy sports car or a giant TV. You can easily forego those if the price jumps.
Makes sense. What's second?
The availability of close substitutes.
Substitutes,
Yeah.
like the cereal example.
Exactly. If there are lots of good alternatives readily available, demand will be very elastic. If one brand raises its price, people just switch. But if there are few or no good substitutes, maybe like a patented drug or the only ambulance service in town, demand will be much more inelastic.
Okay, factor 3.
The share of income spent on the good.
How much of your budget it takes up.
Yeah. If something eats up a big chunk of your income, like rent or maybe gasoline if you have a long commute, you're probably going to be more sensitive to price changes. It's worth the effort to find ways to cut back. So demand tends to be more elastic.
But if it's a tiny expense, like salt or matches.
You probably don't even notice the price change much. Demand is likely very inelastic for goods that are a small fraction of your spending.
Okay, necessity, luxury, substitutes, share of income. What's the last one?
Time. The amount of time that has passed since the price changed.
How does time affect it?
Demand almost always becomes more elastic over time. In the short run, you might not be able to adjust much to a price change, but given more time, you can find alternatives, change habits, or make different choices.
Like the gasoline example you mentioned earlier.
Perfect example. When gas prices shoot up, you can't instantly buy a more fuel-efficient car or move closer to work. So short-run demand is pretty inelastic, but over months or years, people start carpooling, using public transport, buying smaller cars, maybe even moving. The long-run response is much larger, meaning long-run elasticity is higher than short-run elasticity.
That's a really clear illustration. Let's apply these factors. College tuition is something that keeps going up way faster than inflation sometimes. How elastic is the demand for college?
College tuition. It's a fascinating case because the elasticity varies.
Varies how?
Well, studies generally find that for traditional four-year colleges, overall demand is inelastic. A PED somewhere between 0.6 and 0.75 maybe. So a 3% tuition increase might only cause enrollment to drop by about 2%.
So colleges can raise tuition without seeing a massive exodus. Why? Inelastic. Necessity. Lack of substitutes.
Probably a mix. For many, a four-year degree is seen as a necessity for certain careers. And while there are substitutes like online learning or trade schools, they aren't always seen as close substitutes.
What about two-year community colleges?
Their demand tends to be more elastic, though still generally inelastic overall, maybe a PED around 0.9.
Why higher for two-year schools?
A couple of reasons are suggested. Often, two-year students pay more out of pocket, so tuition is a bigger share of their income. Also, they might see school as a more direct substitute for working, so if job prospects look good, a tuition hike might push them towards work.
Interesting. And does financial aid change things?
Dramatically. Studies looking at students who receive financial aid find their demand becomes elastic, with a PED around 1.8.
Elastic. Why would aid recipients be more sensitive to price?
It seems counterintuitive at first, right? But they might be looking at the total sticker price, fearing that future aid might decrease, or worrying about the loans they'll have to repay. It suggests students care not just about the net price today, but the overall cost and financial structure. They might actually prefer a lower sticker price, even if it means slightly less aid, perhaps for the certainty.
That's a really subtle but important finding about student behavior. Okay, so we've talked a lot about how demand responds to its own price. What about how it responds to other things?
Right. There are two other key demand elasticities. First, the cross-price elasticity of demand.
Cross price between two different goods.
Exactly. It measures how the quantity demanded of good E changes when the price of good B changes. Formula is percent change in quantity of A% change in price of B.
And what does this tell us?
It tells us if the goods are substitutes or complements, and importantly, here the sign, positive or negative, matters.
Okay, how does this sign work?
If the cross-price elasticity is positive, the goods are substitutes. Think hot dogs and hamburgers. If the price of hot dogs goes up, positive percent change. The quantity demanded of hamburgers goes up, positive percent change. Positive divided by positive is positive,
And the bigger the positive number.
the closer substitutes they are.
Okay. What if it's negative?
Then the goods are complements, things used together. Think hot dogs and hot dog buns. If the price of hot dogs goes up, positive percent change, people buy fewer hot dogs, so they also buy fewer buns. Negative percent change. Negative divided by positive is negative.
And a more negative number means stronger complements.
Exactly. Like cars and gasoline might have a strongly negative cross-price elasticity.
Got it. Substitutes are positive, complements are negative. What's the other demand elasticity?
Income elasticity of demand. This measures how the quantity demanded changes when consumer income changes. It's percent change in quantity, demanded percent change in income.
And what does this tell us?
It tells us if a good is normal or inferior.
Normal versus inferior. How does that work?
Most goods are normal goods. As income goes up, people demand more of them. So the income elasticity is positive.
Oh.
Within normal goods, we can distinguish further. If the income elasticity is greater than 1, it's income elastic. Demand rises faster than income. Think luxuries, second homes, international travel.
And if it's positive but less than 1?
It's income inelastic. Demand rises, but slower than income. Think necessities like food, clothing. You buy more as you get richer, but not proportionally as much.
So what are inferior goods then?
Inferior goods are those where demand decreases as income rises, so they have a negative income elasticity. Maybe things like cheap instant noodles or bus travel for some people. As their income increases, they switch to higher quality food or buy a car.
That makes sense. You mentioned food being income inelastic. Does that show up in global spending patterns?
Very clearly. If you look at data comparing countries, poorer countries spend a much, much larger percentage of their total income on food than richer countries do. As incomes rise globally, the share of income spent on basic food falls, even though total spending might go up. It's a classic sign of an income inelastic good.
It's interesting how these concepts play out on a large scale. We've covered a lot on the demand side.
Yeah.
But what about the suppliers? Do they have elasticity too?
Absolutely. We need to look at the price elasticity of supply, or PE.
PEs, okay. Analogous to PE.
Very similar concept. It measures how responsive the quantity supplied by producers is to a change in the price. It's the percent change in quantity supplied, percent change in price.
And since suppliers usually want to supply more at higher prices, this will generally be positive, right?
Yeah.
So no need to drop a minus sign.
Correct. Price and quantity supplied typically move together, so PE is usually positive. We use the same midpoint method for calculations to ensure consistency.
So a PS greater than 1 means supply is elastic. Less than 1, inelastic. Equal to 1, unit elastic.
Exactly the same interpretation regarding responsiveness. A piece of 2 means a 10% price rise leads to a 20% rise in quantity supplied, very responsive, elastic supply. A P of 0.5 means a 10% price rise only brings forth a 5% increase in quantity supplied, inelastic supply.
Are there extreme cases here too? Perfectly inelastic and perfectly elastic supply.
Yes. Perfectly inelastic supply, PAS equals 0, is a vertical supply curve. The quantity supplied is fixed, regardless of price. Think about, say, the number of original Van Gogh paintings. You can't make more no matter how high the price goes. Or maybe cell phone radio spectrum frequencies, the government allocates a fixed amount.
Okay, fixed quantity. What about perfectly elastic supply?
That's a horizontal supply curve, PEF equals infinity. It means producers are willing to supply any quantity at a specific price, but nothing below that price. If the price rises even slightly above that, they theoretically supply an infinite amount. This happens when inputs are easily available at a constant cost, like maybe pizza production in a large city with lots of suppliers and readily available ingredients.
So what determines if supply is elastic or inelastic in general?
Two main things, similar to demand. First, the availability of inputs.
Can producers easily get the stuff they need to make more?
Right. If inputs, labor, materials, machinery are easy to get and relatively cheap, producers can ramp up production quickly when prices rise. That leads to elastic supply. But if inputs are specialized, scarce, or take a long time to create, like highly trained surgeons or complex manufacturing facilities or specialized ambulance equipment, then supply will be more inelastic. It's hard to increase output quickly.
Makes sense. What's the second factor?
Time. Just like with demand, supply becomes more elastic over time.
Producers need time to adjust.
Exactly. In the short run, a farmer might not be able to produce much more wheat even if the price spikes because the land is already planted. But give them a year or two and they can shift acreage from other crops to wheat, buy new equipment, etc. So long-run supply elasticity is usually much higher than short-run.
This time factor sounds like it played a big role in that global commodities glut you mentioned earlier. Can you walk us through that?
Yeah, that's a really powerful and painful example for producers. What happened was during the boom years, especially with China's rapid growth, demand for commodities, copper, coal, iron ore, natural gas soared. Prices went way up.
Okay, high prices.
Yeah,
Signal to produce more.
right. And crucially, capital was pretty cheap and available. So companies all over the world invested billions, building new mines, drilling new wells, expanding capacity like crazy. They were responding to the high prices.
They were increasing their long-run supply.
Massively. But then around 2015, 2016, China's economy slowed down. Demand for those commodities dropped off significantly.
But all that new supply capacity was already built.
Exactly. You can't just easily shut down a massive new mine or gas field that took years and billions to build. So producers kept producing, even with falling demand, because the marginal cost of operating was still relatively low compared to the huge initial investment. This flooded the market.
Leading to a price crash. The supply, which they had made very elastic in the long run through investment, overwhelmed the falling demand.
Precisely. The high prices and easy capital encouraged a huge supply response. When demand faltered, the elasticity of that supply worked against them, worsening the glut and hammering prices. It shows how producers, if not careful about collective supply responses, can sometimes be their own worst enemies.
Wow. Okay, so we've covered a whole menagerie of elasticities. Price elasticity of demand, PED, cross-price income, and price elasticity of supply, PES.
Right, and we've seen how PED relates to total revenue, cross-price tells us about substitutes and complements, income about normal and inferior goods, and PES about producer responsiveness.
The concept seems straightforward, but the applications are everywhere. Let's bring it home with another big example. The U.S. airline industry. They used to lose money constantly, now they seem quite profitable. How much is elasticity playing a role there?
A huge role. It's a masterclass in understanding and leveraging elasticity. First, remember the industry consolidated significantly. Fewer major players means less intense price competition.
Okay, less competition. What else?
After the 2008 recession, they deliberately adopted a strategy often described as fly less and charge more. They cut capacity, flew fewer flights, used smaller planes, made sure planes were fuller.
Reducing supply, which, given somewhat inelastic demand for many trips, would push prices up.
Exactly. But they also got much smarter about pricing based on elasticity price discrimination.
How so?
Think about ticket prices. Why is it often cheapest to buy on a Tuesday for a Wednesday flight and most expensive to buy last minute on a Friday? They're segmenting customers.
Leisure travelers versus business travelers.
Largely, yes. Leisure travelers often plan ahead, are flexible on dates, and are very price sensitive. Elastic demand. Business travelers often book later, have fixed schedules, and their companies pay, making them less price sensitive in elastic demand. The airlines charge different prices to capture maximum revenue from each group.
That makes sense. And then there are all those fees. Baggage fees, seat selection fees, food.
The ancillary fees. This is another brilliant move from their perspective. Once you've bought your main ticket, especially for a trip you have to take, your demand for things like checking a bag or getting a decent seat becomes much more inelastic.
You're kind of locked in.
Pretty much. So they can charge quite a bit for these extras, and people often pay up. It's become a massive part of their overall revenue, sometimes more than the profit from the ticket itself.
It really shows how understanding elasticity, down to specific customer segments and add-on services, can transform an industry's profitability.
Absolutely. The whole game is managing capacity, supply elasticity, and pricing according to varying demand elasticities.
So, wrapping this up for our listeners, understanding these ideas, PED, PES, cross-price, income elasticity, it's not just academic jargon.
Not at all. It's a lens. It helps you understand why the price of gas fluctuates, why companies offer sales or charge different prices, why certain government taxes have specific effects, how markets adjust.
It equips you to analyze business strategies, policy impacts, and just everyday economic events you see around you. Hopefully, thinking about elasticity will make things click, whether you're in a class, studying for an exam, or just trying to make sense of the economic news.
That's the goal. Start looking for it. You'll see elasticity principles at play everywhere once you know what to look for.
Definitely. So here's a final thought to leave you with. Considering how powerful this understanding is, how airlines use it, how ambulance pricing reflects it, how might businesses, or even governments, use increasingly precise measurements of our responsiveness in the future to intentionally shape our behavior or market outcomes even more? Something to ponder.
A slightly unsettling but important question.
Indeed. We really hope this deep dive into elasticity has given you some clear insights and useful tools. From the whole team, thanks so much for tuning into the deep dive.